Today we're going to be talking about volume of cones and pyramids, specifically a cone. So I have here our problem, which is a cone's lateral surface is created by a half circle with a radius of 30 inches. And so with that information, I started with this little chart here, and I took from the lateral portion. The radius is 30, and since we know the diameter is, or the radius is half of the diameter, I made the diameter 60. So then the circumference of the full circle would be 60 pi. The length of the arc would be 30 pi because that would be half of the circle. And automatically I already know that these two would be the same because they basically mean the same thing. The area of the full circle will be 30 times 30 pi, which you'll get 900 pi. And then the partial circle is going to be half of that since it's a partial, so you make that 450 pi. And then moving over onto here, you are going to basically use the radius with the diameter for the base. So taking 30 and dividing it by half will be 15. We already know that's 30 pi because these two need to be the same. And the area of the base is 15 squared pi, which also equals 225 pi. So the surface area will be 450 pi right here from the partial circle plus 250 pi, which will equal 675 pi squared inches. You're going to take the height squared plus 15 squared equals 30 squared, so that will be 900 minus 225, giving you the height of the square root of 675. And then to find the volume left here, you're going to do volume equals 1/3 times a base times height, which you will substitute a base for 225 pi and the height for what we just found here, which was square root of 675, to get 6,121.6 inches cubed.